Welcome. Let's take a look at finding the antiderivative of a function that involves trigonometric functions. So here we have the antiderivative of 2 times secant squared of x plus cosine of x dx. So the integral is linear, which means that I can separate addition and subtraction into separate integrals. That means that I can rewrite this as the antiderivative of 2 times the secant squared of x dx plus the antiderivative of cosine of x dx. Additionally, the linearity allows me to factor out any constants in front of my functions. So this 2 that I have in front of my secant squared, I can bring in front of the integral symbol. And what this does for me is it allows me to focus my attention on what is the antiderivative of secant squared. Let's go ahead and copy down the rest of the antiderivative here. So we have now 2 times the antiderivative of secant of x dx plus the antiderivative of cosine of x dx. Now at this point in time, we need to rely on our knowledge of derivatives. Recall that the derivative of the sine function is the cosine function. Because of that relationship, the antiderivative of the cosine function is the sine function. So for this second term, the antiderivative of cosine is sine. So when I take that antiderivative, I don't need that symbol anymore. And now I simply have sine of x plus c. Looking at our first term, we have 2 times something. Now, the derivative of the tangent function is secant squared of x. That means that the antiderivative of secant squared of x is going to be tangent of x. So we have 2 times tangent of x plus sine of x plus c. Now, you could, if you were concerned, you could put a plus c1 after the tangent antiderivative of secant squared, and you could put a plus c2 after the sine of x, and when we combined constant c1 and constant c2, we will end up with simply a third constant, and that constant just represents all possible constants. So we simply combine them, and we say that our antiderivative is 2 tangent of x plus sine of x plus c. I hope you find this helpful.